converting this Sieg X2 to a CNC operated machine. Well, actually what I'm doing is I'm designing a kit which will be closely resemble what you see me making in these videos. Obviously you'll see 2 parts of aluminium here making up this bearing block. It will be cast in one casting and then machined and things like that. But I hope you enjoy what you see here. Okay, so I've got some insulation tape. Actually, it's electrical insulation tape. It's very tough. Just on here and onto here, because it's a bit of a pain actually trying to get this off the screw. You can do it, and I'll demonstrate afterwards how it's done. But this particular case, it's quick for me just to put a bit of tape on here, make sure no shavings gets into the ball screw. And what I've done, I've already cut this off with the angle grinder, as you saw just now. I faced it off, put a center drill in, and now, because this material is so hard, and it is, you know, sort of protruding or stuck out from the end of the chuck, you know, a good 4 or 5 inches there. Actually, nearly 6, between 5 and 6 inches actually. And it's 16 mil diameter. It will tend to bend or flex if I didn't have some support this end. Also, it would chatter, and it'd probably end up bending the bar. So you have to support it, and I'm supporting it with what they call a live center. This cone or center here actually rotates with the material. There's a bearing inside here. So this is why this is called a live center. If this just was put in the tailstock here and didn't turn, that's called a dead center. Okay, so now I'll start to machine this up to this point here, and I'll show you how tough this damn stuff is. Here we go. Yeah, easier the material is cutting now, because now I've broken, well, there's the hard material down to there. I've just broken through to it, to the softer material, but in the center it's even softer again. So it is a little bit like a samurai sword. And what I'm going to do is I'm going to deliberately leave this slightly rougher finish, so this has something to grab onto, and I'm not going to get any slippage there. So that actually took, if you see the time there, 5 minutes 51 seconds. So Gwen can actually be quite efficient in cutting these sort of things out. That's 12mm of aluminium, and it's about 70mm square. So the feed rate was let me see if I can remember what it was. You can see that I was running the program at 100%, and the feed rate from memory was 10mm a second. So that's what 10mm a second looks like, running a CNC router, and the depth of cut was 0.5mm each time. So it took 24 cuts to actually do the 12mm, but you can say that's fresh off the machine. It is near perfect. I mean, that's straight off the machine. Yeah, it's got a couple of burrs on the edges, but it's very, very clean. And you'll notice that the shavings that come off these CNC routers, when you run them at the right speed and the right feed, the shavings come off cleanly, but you do need to evacuate them with either air or some method, or sometimes you can use a vacuum as well, but I prefer to use air because it keeps the material and the tool cool. Plus I use WD-40 as a lubricant and cutting aid, and it makes a damn good one too. Sometimes a picture, or in this case a video, can tell a lot about a story or a piece of work or whatever you're doing than what an explanation can. So this is the most efficient way of cutting a thread en masse. A little bit of lubricant, WD-40, wonderful stuff. A good tap, a good cordless drill, and the right size hole. It's as simple as that. Of course, these are the, shall we say, the flanges or mounting blocks for the stepper motors. So these are the three, shall we say, mounting extensions for the stepper motors. Stepper sort of operates like this. This particular one is the Z. What I've done is that they are a common design, but they are three different sizes. And actually, in this case, this is the Z. This one is the Y, and this one's the X. Okay, this particular unit is the Z, just happens to be the largest. So you can see its construction. It's very, very solid and very, very square. I don't know if you can see the inside of that. I've actually machined slight flanges down inside there, so this will go down so far and stop, and it's absolutely square, as you can tell. So those are the holes I was just drilling and tapping. They line up perfectly with this, so this perfectly fits in like so. But now what I have to do is to drill 4 holes. Well, actually I'm going to leave that till much later because I haven't actually made the Z axes as yet. So I want to get this up to a stage where the last piece of the puzzle then, which would be bolting this onto each axis. So what I'm going to do, my next job now, is to, on the 4 flat areas here, drill a clearance hole and then drill into this block here and thread it. And then countersink here, so I can put, I don't have them here, so I can put these countersunk Allen head screws in on each flat, like so, on each flat, on both ends. Really, that's all required. That's all that's required for this. They will do the job quite nicely. I mean, these are not exactly a press fit, but they're a nice tight fit in there. They can't go anywhere. They're on a ledge as they go down in. As you can see, they fit perfectly. And so you just need something to lock them into position. Really, they're just taking the weight of the motor relay. Yeah, so all good. Okay, so what I require now, and I've set this up to do this operation, is I have a 4mm hole in here, and I'm going to put a 5mm thread in it, but I want a clearance hole in this outer part, and I want the threaded part in here. So I'm set up now, and I've set the depth gauge here to cut the distance of this outer shroud then. A clearance hole, so that's what we'll do now. And there we are. You can see the clearance hole there now on all of them, and it's done with a very, very simple jig. And of course we're cutting aluminium, so it's quite safe to do so long as you have the material trapped in such a way that it can't, if it gets grabbed by any means by the drill, it's not going to fly out anywhere. And it's quite safe to do it this technique then. So there we go. operation now is just getting rid of the burr on the inside. Simple as that.